Section 7.3.1 IP Addresses and Subnet Masks, Part 2. It is the subnet mask that informs the system which parts are network and which are host. So when a device receives an IP address, it comes with a subnet mask which identifies the network part of the address. These are two examples of what the IP address configuration would look like. We have an IP address and also a subnet mask. Any octet in the subnet mask that is filled with 255 will be part of the network identifier. It is the subnet mask that informs the system which parts are network and which are host. Any octet that is filled by 255 will be part of the network identifier. The numbers listed in the first octet column refer to the beginning octet of an IP address. Note that 127 is missing intentionally. I'll explain that in a bit. This octet will tell us what the subnet mask will be. The parts of the subnet mask that are all ones is the network part. In the graph here, N refers to the network portion. In the first row, the subnet mask of 255.0.0.0 means that the first octet of the address is 8 bits, and they are being used to identify the network. Another way of looking at it is that the subnet mask is saying, hey, hands off these 8 bits. Don't use them for host addresses. They are being used already for net ID. We're using binary, so that means those are on and not available. The parts of the subnet mask that are all zeros is the host part. In the graph here, H refers to the host portion. In the third row, the subnet mask of 255.255.255.0 means there are only 8 bits available to create unique host addresses. Here is an example. A network uses 197 as the first octet. Looking at the graph, I see they use the default subnet mask of 255.255.255.0. The IP addresses they have available to distribute to computers, printers, and other devices are 197.0.0.1, 197.0.0.2, all the way up to 197.0.0.254. While the maximum value of an octet is 255, this digit cannot be assigned to hosts. An important concept to remember is there is no requirement to use the default subnet mask. There are situations when a network admin would configure a custom subnet mask. Here's how that configuration would impact the network. When the subnet mask is 255.255.0.0, then the first 2 octets of the IP address identify the network. In this example, both PCs will be in network 172.15. They have the same first 2 octets. When the subnet mask is 255.255.255.0, then the first 3 octets of the IP address identify the network. We can see how in example 2, the PCs are not in the same network because the first 3 octets are not the same between the 2. PC number 1 will be in the 172.15.24 network, and PC2 will be in the 172.15.50 network. The subnet masks are how connection devices like routers and switches identify which host devices belong to a network. Custom subnets are typically used to create segmentation of a network. The network administrator can institute security by reducing the size of the network, which will limit which devices can communicate with each other and how far malware or hackers can reach into the network. Network segmentation is a key security best practice, but it adds extra work to configure and extra cost to add routers between the segments. As with many other security practices, network segmentation is often skipped or minimized due to the cost and inconvenience. It does allow us to achieve two of our cybersecurity goals of limiting which internal departments can exchange information and limit how far an intruder or malware can reach into the network.